The dominating question of today's lesson, which is nice that there's just one dominating question, is the following. When is the dude furthest to the right? Or when is the dude furthest to the left? Okay? Translate that question. If I ask you, what is the guy furthest right? Think of it in terms of things we've done in this calculus class. What are we going to try to find? Good. First things first, we translate this question into finding a max position or a min position. Okay? For most of the questions, I'm asking you to find a max or a min of a position. Now, I will sometimes ask you for a max or a min of a velocity, and we'll talk about that. But most of the questions are max min positions. Okay? We know how to find maxes and mins in this class. You take derivatives and you set them equal to 0. You want to find the max of something. You want to find the min of something. You take the derivative of that something. It might be a first derivative. It might be v. You take the derivative, you set it equal to 0. All right? Take the derivative, you set it equal to 0. You take your derivative, you set it equal to 0. You analyze the signs of your derivatives. Boom, 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 and then you say, hooray, I got a max. Hooray, I got a min. Right? Right? That's not new, right? Sometimes they give you the derivative. Okay, great. Well, I don't have to take a derivative. It's already given to me, but I need to analyze the sign. Like boom, boom. F prime's telling us about F. There's a max, there's a min, right? No big deal, no big deal. Not new, but what we had found were relative maxes. This is a relative max. It's a relative min. We are now going to be asked about absolute maxes, like furthest right, overall, absolute max, like our overall max. And the problem is if you have like an analysis like this or like that, you realize your original function probably looks something like this. Goes up, goes down, goes up. And you're like, okay, yeah, here's my max and here's my min. But would you call those overall maxes and mins? No, because you keep going up. So like you will never reach a max. You'll keep going down, so you'll never reach a min. So this is why, first thing is first, the questions about furthest right, furthest left, you will be given an interval. A closed interval. What do I mean by a closed interval? You would be told, hey, start here, disregard all of this, we don't care. And here, disregard all of that. Now, what do we notice? Well, this is still our min, but now we can call it an absolute min in our interval. This is still a max. However, there might be a point at the end that is producing a larger value than that max. If you had a graph that looked like this potentially, and you had an interval that looked like this is just an example, you'd be like, oh yeah, that's a min for sure. But maybe I start at a lower value. That could be the overall min. Okay, so heads up, if an interval is given, what do we have to worry about? The beginnings and the ends. Okay, and this is called the extreme value theorem. It says an overall max or a min can be at a relative max or a min or at an endpoint. When do we have relative maxes and mins? When we take our derivative and we set it equal to 0. So if you're given a closed interval, you ask for maxes and mins, here are your candidates. We call these candidates, and from the extreme value theorem comes like candidates test. Like what could be an overall max? Well, the candidates for an overall max are when my derivative equals 0 or an endpoint. Sometimes you don't have to worry about like candidates. Sometimes you can tell for a fact whether you have a max or a min. Like I know if my signs of my derivative are this, I know what I have. I'm certainly going to have this here. What do I have and where? Tell your neighbors. We are definitely not just going to have a relative max, but it's got to be what we call an absolute or an overall max. It has to be. Because over this closed interval, f has to go up then down. Well, that's got to be the largest point. Sometimes you don't have any candidates as long as you understand the signs of your derivative. But then when I ask you for the min, which location? Well, there's two things we could do. If we are able to look at the f of x function, the original function, we could actually just find the values and compare them. Right? But if we weren't able to, maybe just like on your quiz, when you're not able to take an antiderivative and find what f of x is, what you're going to have to do is analyze your displacement. And you're going to have to see, oh, after knowing my displacement over my interval, I know which part is going to be the max or the min. This is still the max. This first point has to be the location of the min. Because what I do is increase by 5, and then I just decrease by 2. I add 5 from here to here, and then I subtract 2 from there to there. This must be the location of the absolute min at an endpoint. That makes sense? That's pretty much what we're doing. Sometimes you'll have one sign change, which means there's less things to check. There's more things you can definitively answer. Sometimes there'll be multiple sign changes. And you'll see on your homework, and I get frustrated while I'm doing the homework, because like really early on, there's lots of sign changes on the important problems. I tell you that the first 2 pages of your homework are less important than the next 2 pages. Make sure you know that. If you guys have your homework, like pages 3 and 4 are more important than pages 1 and 2. When there's multiple sign changes, there's candidates. This could be the max. This could be the max. This could be the min. This could be the min. So you're going to have to do more analysis of your displacements to figure out, you know, maybe your relative min is the overall min. Maybe an endpoint is the max. Maybe the relative to the max is the overall max. You're just going to have to do the math, okay? Let's just get to the problem that really makes sure you understand what's going on, and that's this first graph problem. If you understand this graph problem, I think you're good. Pages 1 and 2, you'll be able to check your candidate's values by just plugging it into the original, but that's what doesn't trip up students. This is what trips up students, okay? So you're given the graph of velocity, just like we've seen before. You're given the areas. You're given your position at some time. If you, just like you did on today's warm-up problem and on your quiz, if you are able to do your analysis of your derivative, your analysis of velocity, and able to interpret things correctly, I bet you can answer this. So see if you can do it. Ready, set, go. I'll just walk you through this one really quickly. Maybe some of you are already there, some of you aren't. Our velocity is positive than negative, which means our position is increasing than decreasing. My position is increasing a total of 7 until time 2, and then it's decreasing 3 from 2 to 4. Cool? Don't forget to find your initial position, whether that's at time 0 or like at time 4 or somewhere in between, so you know, okay, I started at a position of 5. I increased 7 over the first 2 seconds, so I get to a position of 12. 5 plus 7 is 12. I then decrease 3, and my position at time 4 is 9. These are your candidates. Furthest right, furthest left. If I ask you to justify, I'm not going to worry about you justifying and like saying why right now. We're going to like work our way into writing statements. But you're going to be like furthest right, furthest left is when your derivative equals 0 or an endpoint. Your candidates are x of 0, which is 5, x of 2 is 12, and x of 4 is 9. These are your 3 possibilities. One is when the derivative equals 0. Here's my endpoints. These are my 3 values. Furthest right, x of 2 is 12. Here's my time. Here's my position. Furthest left, the smallest value of my other candidate. You didn't have to find the values, really. You knew that 2 has got to be the max because you increased 7. You knew 0 has to be the min because you increased 7 and just decreased 3. Okay, so an endpoint, a relative max, you know, that's all what we're looking for. All right, you guys try this one. If you didn't pick up the first one, maybe you'll pick up this one a little bit quicker. When are we furthest right, furthest left? Here's the position and a time given. Answer. Tell your neighbors. Go. Don't say it yet. Somebody's working on it. Okay, never mind. Sorry. You just said, I think you just said that it's starting to make too much sense? All right, good. That's honestly good for me to hear, because this has been disastrous in the past. Yep, that's it. That's it. I didn't do everything like I do now back in the day. All right. You know the signs of your derivative. You know the areas under your derivative. You know the displacement, therefore. You know how much you're increasing, how much you're decreasing. You know. Did that just come out?
Yeah.
Woo, let's go! Woo! Yeah! Woo! Oh, that screws up everything for teachers. So, like, you guys will be taking the test before the A-Day students. That's how it works, you know? You guys will have the Unit 7 test here. And then the A-Day students will have the Unit 7 test there. We're flip-flopping who's in front. That's what happens. It's so soft. We're so soft sometimes in Texas. God. Oh, man. Hold on. Bring it back together. Bring it back together. So, that means x of 5. Lock it in. Lock it in. Lock it in. I will see you in 2 days. You will be taking a quiz. Okay. X of 5 is 3 because you increase 2 to get to 5. So you do the opposite. X of 3 must be 7 so that you decrease 4 to get to 3. You're doing the opposite. We're going backwards. X of 1 must be 1 because you increase 6 to get to 7. I'm like, now that I'm putting these here, I think it makes sense a lot better. Yeah, me too. X of 0 must be 4 because you decrease 3 to get to 1. Got it? These are all of your candidates for the furthest right, furthest left. It's when your derivative is 0 and it's your endpoint. So, some things, though, to be worried about for the future, for the AP exam. They won't accept the ways that you got these answers like this. You're going to have to show, oh, x of 6 is 5. X of 5 is 3 minus the integral from 5 to 6 of b. X of 3 is, and you got to 5 minus the integral from 5 to 6. And then x of 3 is equal to x of 5 minus. So it's like, it's annoying that you have to show this, but it's necessary for your AP exam. For right now, guys, though, I just want you to get the right answer. You just compare the values. 7 is bigger than all of the other ones. So furthest right, x of 3 is 7. Furthest left, x of 1 is 1. Okay, cool. All right, now, team, this is page 3, okay? This is page 3 of your homework. This is not page 3 of your notes, but this is page 3 of your homework. This is the most important page. Change your interval, though. I don't want us to go crazy. Let's go 0 to 3. Screw it, 0 to 2. 0 to 2. Let's go crazy. Let's go easy. Okay. This is the same as really the graph problem, the 2 graph problems we just did before. Okay? You are given a velocity. You are unable to take its antiderivative to get a position function. What you're going to have to use is your initial position, an analysis of your signs of your velocity to figure out what are the candidates, and then what are my positions and who wins for furthest right and furthest left. Got it? So, for these situations, you have a calculator. I would never ask you this question without a calculator. You must graph your velocity. So everybody, let's graph your velocity. We're going from 0 to 2. You should start getting used to this process because you're going to do it a lot this unit and next unit. Three log x sine x minus 2 minus 3 from 0 to, oh, I didn't change my window. Press on to pause. I'm going 0 to 2. 0 to 2, zoom, fit. If we haven't figured out how to do this, you haven't been doing your homework. Now, the first thing you should be saying is, hooray. There are 0 or 1 sign changes. That makes a lot less calculations necessary. Once there's 2 or 3 sign changes, then you're like, frustrating. On your test, one of the derivatives will have 0 or 1 sign changes, one of them will have 2. And you got to understand, oh yeah, that's the graph of my derivative. That is the graph of my derivative. Here is when we realize it's not just whole numbers, but my derivative is positive until some value that I don't know, but I'm going to call a, and then it's negative after that. That means my position is increasing and decreasing. I'm traveling to the right and then to the left, if we're talking about on a line. We know for a fact, A, that time is when I'm going to be furthest right. You know that, okay? But you might as well just like figure out furthest left while we're out there. If you're asking for just furthest right though, you can have this done. You just got to be like t equals a, must be the max. V is positive until a and negative after a. You're done. You don't have to worry about candidate. If you want to figure out right and left, you're going to be like, all right, we're going to have a max min position when x prime, which equals v, you don't have to say both, just say one or the other, equals 0 or an endpoint. Right? This is literally the extreme value theorem. This is saying these are where candidates come from for maxes and mins on a closed interval. All you need to do is find x of 0, x of a, and x of 2. X of 0 is already given to you, it's 3. You know x of a is going to be 3 plus, you're going to go from 0 to a. You know x of 2 has got to be x of a plus your integral from a to 2. Now, this is stuff that you guys probably don't like to write down or it makes no sense to you. But let's just get our answers here, and then hopefully you'll see it down here. Like, ready, set, let's go. We need to find this intersection. Mr. Messer always likes to have y equals 0 graphs in the background. That way, we can just second calc intersect rather than finding a 0. We good? We find a's value is 0.367. I probably write down the entire value since I need to use it. 17118. But what does Mr. Messer like to do? Take that found intersection and store it. If you have not done this, please pay attention very closely. Once you find an intersection in the home screen, it's stored as x. We said it's a, so let's store. This store button is above the on. Store that value as a. Now, we can break out our friend Mr. Integral to figure out how much my position increases, how much our position decreases by finding the area. I prefer to do this in the home screen versus seeing it because I can use these numbers more easily instead of having to write them down. 0 to a of 3 log x, close your parentheses, sine x minus 2, close your parentheses, minus 3. dx. You press enter, and look, your calculator's taking a while to figure this out. This is like a good indication that it's doing an arithmetic process. It's not taking an antiderivative. This is 0.998. You have x of 0 is 3. Take that 3, add 0.998, and now we have x of a. That's 3 plus the integral from 0 to a of b. 3 plus 0.998. And poof. This is our max position, I know for a fact. X of a, which is 3.998. Sorry for this being so busy and crowded. Now, we'll go ahead and do our integral from a to 2. Grab it, press enter. You don't have to retype it. Back yourself up. Go from a to 2. You will figure out how much you decrease. You go down 4.506. You have this number. You go down 4.506. You'll find your position at time 2. Take a, add your displacement from a to 2. Take a, add your displacement from a to 2. Take your position at time a, add your displacement from a to 2. And you get negative 0.507. That's negative 0.507. I hope this makes sense. It's just what we do with our graphs of v. It's just like with decimals, and takes a lot longer than just looking. Yeah, don't round that to 4. Just write down 3 decimal places. It's called truncating. Don't worry about rounding. People make mistakes when they round. So after you've listed off your candidates, boom, you would just then label this as your max. This is at your min based, and that's all you need to do, okay? If you say, here's where my candidates come from, it's when my derivative equals 0 or endpoints, you list off your candidates, you win. If you were asked to find a max and you had this statement down and you didn't have the endpoints because you know that's a max, you just need like extra statements saying why you don't have to look at the endpoints. It becomes a little bit annoying and cumbersome. Some people like doing it, some people don't. We'll focus more on that in the future, okay? Okay. Change this question. No calculator. X of t is 3t squared minus 6t. One is the particle moving fastest to the right. Okay? This is the other type of question that shows up on page 2, which a lot of students have difficulty with. And we'll talk about the interval from 0 to 3. Okay, translate the question. Fastest right is what? Tell your neighbors. Fastest to the right. Okay, here's what we need to go. Ready? Particle is fastest to the right when the velocity is at a max. Start with that. Now, how do we find one of velocities at a max? Here's where students make huge, huge errors. Okay? They kind of understand what to get, but they just start doing work before they understand, like, what to get. Like, they understand that, but then they don't understand how to get when velocity is at a max. How do we figure out when velocity is at a max? How do we figure out when anything's at a max? Tell your neighbors. You need to figure out when its derivative is 0 or an endpoint. A lot of people in this question would take the derivative and set it equal to 0. But no, skip this. I need to figure out when this is a max. I need to take its derivative, set it equal to 0. Well, its derivative is 6. I can't set it equal to 0. Oh, what is that telling you? From 0 to 3, velocity's derivative is positive. That means velocity must be increasing consistently, which means your velocity at time 3 must be the max. And that makes sense. It's a linear function, velocity 60 plus x, plug in 3, you get 12. That's it. So make sure you understand, like, yes, most of our questions will be furthest right, furthest left. Max of position, look at velocity signs, do your sign analysis of velocity. But be careful. Sometimes they ask you, when does velocity have a max? Look at velocity's derivative and do a sign analysis of it. That's it, guys, okay? I think if you understand the graph and you understand how to use your calculator, you guys are good. It's not. Everybody just told me it's gotten easier. If you understand this graph, Ember, then you good.
So from like the previous units, like 1, 2, 3, 4, 5, 6, it's so much harder.
All is added as one level to our sign analysis of our derivative.
This thing throws me off, though.
Yo, just watch my homework video.